So we saw last time the different kinds or classification of the acid and bases. Now we see the next part, that is formation of hydronium and hydroxide ions for acids and bases, alkalis respectively. So first is called as the Arrhenius theory. Acids are substances which dissociate in aqueous solution to form H plus ions. Strong acid dissociate almost completely, while weak acid dissociate partially. This is called as Arrhenius theory. Now, Arrhenius theory is much more important in case of electrolysis, but yeah, you can understand it this way, that it stated that when the H plus ions which are generated from an acid are more, then it is a strong acid, and if the H plus ions which are generated are less, then they are a weak acid. So that is exactly what we saw in the classification of strong and weak acids. The another one is also a Lowry Bronsted theory. Bronsted theory. Acids are proton donors, bases are proton acceptors. So when you can see HCl may H plus and Cl minus is there. So here acid is a proton donor, because we can see over here that is HCl is there. It has been going to become H plus and Cl minus. Now this H plus is going to go to H2O to form into H3O plus. So here what has happened? The HCl has donated its H plus proton. That's why it is called as the proton donor. So this one HCl is a proton donor. Okay. So proton donor is an acid, whereas in case of NH3, if you see an NH3, at that time when H plus is going to be added up, it becomes NH4 to give you a base. Ammonium is a base, hence it is a proton acceptor. It's a proton acceptor. Okay, here H3O के जो we know that lone pair of H3O will be lone pair of NH3 will be taking one H over here. So it is taking one H plus ion, hence it is a proton acceptor. This is how it was defined in the form of by Lowry Bronsted theory. Now we see actually what happens when hydronium ion is formed. How a hydronium ion is formed? We already learned this in the chemical composition, chemical for bonding chapter, but we will just go through it once again. So it's a very simple thing over here, that there is oxygen over here and a water. So water molecule like this. This is the water molecule, and when this water molecule is going to have this two as the lone pair, and if there is one H plus which is going to come over here, how does the H plus come over here? It could be from an HCl or something, so it is going to come over there. So what it will be having will be something like, there is an HCl over here. This HCl over here is going to turn in this way, that it becomes H plus and Cl minus, because it is going to give away its electron to chlorine. So this becomes H plus, and that H plus is going to come and settle over here. So it forms into H cross dot cross C O dot 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 cross H, and here H, and then plus Cl minus. So this formation over here is hydronium H3O plus. So this is how the hydronium H3O plus is formed. It will still have a lone pair over here. This is the lone pair of the hydronium, and so here, and this Cl minus will be remaining. So a proton H plus release. So we can see a water molecule. A water is a polar covalent molecule and exhibits charge separation. A hydrogen atom of water carries a slight positive charge, and the oxygen atom a slight negative charge. So that's the differential positive and negative charge which I talked about. Oxygen atom in water have two lone pairs of electrons not shared with any other atom. A proton, that is H plus ion, released from the acid, released from the acid adds to the lone pair over here of the electron of the oxygen atom of the water molecule. oxygen atom is H2O, has a slight negative charge, so that's why it is going to come over here. Once it does that, so the H plus ion accepts the lone pair of the electron from the coordinate bond, forming the coordinate bond H3O. Such is the formation of H3O. So here, coordinate covalent bond, the bond formed between the atoms of polar covalent molecules with lone pair and of electrons and an ion which accept the lone pair of electrons. So here, there is this ion which is going to accept the lone pair of this electron. So that is why it is forming a coordinate covalent bond. So coordinate covalent bond is the type of bond formed for hydronium H3O plus. Now let's see the formation of OH ions. So in OH ions, what we are having, we are getting the example of ammonia. So ammonia is going to be this way. There is going to be 3 hydrogen atoms already present, and these are the lone pair. So this over here is the lone pair. Now, when this hydronium ion is going to come in contact with water, that is something like this. At that time, since we know that here also the hydrogen over here is not so satisfied, so this hydrogen over here is going to form into H plus and OH minus over here, and this hydrogen comes and settles over here. Formation of N and dot X H and dot over here with an H. So this is formation NH4. What is remaining now is plus OH minus. So this is how the OH minus is formed. So this is NH4 plus OH minus. So this is how the ammonium, that is ammonium NH4 is formed. So here a proton H plus ion released from the water, a proton H from the water is released from the water and is added on the lone pair of the nitrogen atom of the ammonia molecule. So ammonia molecule is accepting that hydrogen from here, and hence the nitrogen atom of NH3 has a slight negative charge, as we know, based on the polar covalent compound. So because of the polar covalent compound, this thing is happening over here. So here the H plus ion accepts the lone pair. The H plus ion accepts the lone pair of the electron, forming a coordinate covalent bond. So here it is this particular NH3, it is accepting the lone pair. This H plus ion accepts the lone pair to form a coordinate covalent bond. And what is remaining is the OH part, which is nothing but the formation of hydroxyl ion, that is OH in case of an alkali. So that was about the formation of hydronium and hydroxyl ion. We go next to see that how are the acids and bases prepared. So first we will see the preparation of acids, and then we will see the preparation of bases. Now, we have been learning since the 8th standard that non-metals, non-metals, when they react with hydrogen, or when they non-metallic oxides, when they react with water, it forms acid. So it is a general principle that first condition is hydrogen reacting with non-metal gives you acid. Example, H plus Cl2, H2 plus Cl2 gives me 2HCl. So that is how you are going to get HCl, that is hydrogen plus non-metals gives you acid. So that is the first condition, that if hydrogen is directly added to a non-metal, the resultant what we are going to get will be an acid, of course, when dissolved in water. The next one could be a acidic oxide plus water. Okay, acidic oxide plus water gives me acid. Now what is an acidic oxide? A non-metal reacting with oxygen. So it is like C plus O2 giving me CO2. So that is nothing but an acidic oxide. Acidic oxide means non-metal react with the oxygen to form a gas. So that's why acidic oxide like CO2, when it reacts with water, it gives me H2CO3. SO2 plus water will give me H2SO3. Okay, so these are just the simple examples that how are the acids going to be formed by acidic oxide plus water giving me an acid. So acidic oxides like sulfur dioxide giving me sulfurous acid. Sulfur trioxide SO3 will give me H2SO4, that is sulfuric acid. Okay, so that is how you are going to get. Similarly, P2O5, that is phosphorus pentoxide, boil water will give me phosphoric acid, that is PH3PO4. So that is how we are going to formation of carbonic acid, sulfurous acid, sulfuric acid, and the phosphoric acid. Neutral oxides such as carbon monoxide, nitric oxides do not produce acid when made to react with water. Now this is something very important to remember. CO, carbon monoxide, NO, that is nitric oxide, which are neutral oxides. See, these are the acidic oxides. CO2, they are acidic oxide. Whereas CO is neutral oxide. So this neutral oxide, no doubt it is a non-metallic oxide, but it is not acidic in nature. That's the reason it doesn't form an acid. So nitric oxide, NO, does not form an acid. CO, carbon monoxide, does not form an acid. The next one is acid from salts. So if you have a normal salt and you react it with sulfuric acid, a concentrated sulfuric acid, when you react it, so basically it is going to be this way, that normal salt plus non-volatile acid, that will give me another acid plus something more. Okay, plus non-volatile, it will be giving you acidic acid, acidic salt plus non-volatile acid. So for example, over here is KNO3, okay, potassium nitrate, okay, PNO3, which a non-volatile acid is only a concentrated sulfuric acid. So it is conc H2SO4 is going to give you, now it will be such that KHSO4 plus HNO3. So this is how the acid HNO3 is formed from another non-volatile acid from a normal salt. So if you take a salt, now this salt, if this would have been a chloride, you will get sulfuric acid, hydrochloric acid. Okay, so depending on what is the salt used over here, you are going to get different kind of acid over here. Nitrate will give you nitric acid, chloride will give you hydrochloric acid. Okay, so that is formation of acid from a salt. And finally, acid by oxidation of non-metals, that is, you can directly have something that it is something like this. It is going to be S plus HNO3, sulfur plus 6HNO3 is going to give me as H2SO4. This is how. So the sulfur with an acid is going to give you sulfuric acid plus water plus NO2. Okay, so 6, 2, yeah. So sulfur with a nitric acid, strong acid, gives you sulfuric acid. So this is how you are forming the acid by oxidation of any non-metal. So non-metal, when it is oxidized by an acid, it is going to form into a sulfuric acid. So non-metals like sulfur is oxidized by concentrated nitric acid to give me acidic H2SO4. You can see over here, we can go through once again everything. First one, reaction with non-metals. So it is going to be reaction of non-metal with hydrogen to give an acid, H2 plus Cl to give me 2HCl. The next is acid from acidic oxide. Acidic oxide dissolved in water. Acidic oxide dissolved in water to give you acid. So CO2 plus H2O is H2CO3, SO2 plus H2O give me H2SO3, SO3 plus H2O give me H2SO4, P2O5 plus H2O giving me H3PO4. The acid formed above are carbonic, sulfurous, sulfuric and phosphoric acid respectively. Remember, neutral metallic oxide, neutral non-metallic oxides like carbon monoxide and nitric oxide, they do not give you acids. The next one is non-volatile acid reacting with a normal salt. So the non-volatile acid on heating with salt of more volatile acid replaces the volatile acid. So salt of a volatile acid, this is a salt of a volatile acid because it is HNO3. So it is a salt of nitrate. Okay, the nitric acid ka salt hai nitrate. So that's why normal salt plus sulfuric acid give me this way nitric acid. Similarly, last thing is that the non-metal like sulfur reacting with nitric acid will give me the sulfuric acid. That is, sulfur is oxidized by concentrated nitric acid to give acid, that is H2SO4. So sulfur plus nitric acid, sulfuric acid plus water plus nitrogen dioxide. This was the preparation of acids. Now we move on to preparation of the bases. So in case of bases, the first thing is similar to this one. यहाँ पे hydrogen था, उसके बदले भी क्या आएगा? Oxygen. So the base के लिए first thing, this is an acid. This is a base preparation. The first one is oxygen plus metal will give me a base. So base is nothing but metal plus oxygen giving me a base. So 4Na plus O2 gives me Na2O. 2Na2O. Got it? This is an example for metal plus oxygen giving you a base. So reaction of metal with oxygen to give a base is basic oxide. Na2 plus O2, Na plus O2 gives me Na2O, and Mg plus O2 gives me MgO. That is the formation of a base. The next is base from a basic oxide. So when you see any basic oxide, when it reacts with water, it is going to become an alkali. So that's why we have over here basic oxide. The next one similar to this exactly. यहाँ पे basic oxide था, acidic oxide था, वहाँ पे भी basic oxide with water. So it is going to be basic oxide plus water giving me an alkali. Okay, or you can just write base over here, not to confuse yourself right now about the base and alkali. Just see the base because all alkalis are bases. So we have over here the formula, the K2O, or you can take Na2 also, not a problem, plus water, that is, plus H2O will give me KOH. So that is the formation of a base, that is basic oxides dissolves in water, that is K2O plus H2O giving me KOH, that is potassium hydroxide, which is a base. Active metals also react with water to give you base or alkali, that is again the same thing. K plus H2O can also give me 2KOH. Shorter method, instead of going for this and then going for this directly, sodium लिया, potassium लिया, पानी में डाला, हो गया अपना काम. So sodium, but here the only thing is that you are going to get some amount of hydrogen also released over here. So it is going to be balancing like this, that 2K plus 2H2O will give you 2KOH plus H2 gas released. So this is how reactive metals when react with water, active metals when react with water, they give you a base which is an alkali. Now why is it specifically alkali? Because they are dissolving in water. Those substances which dissolve in water, those bases which dissolve in water are called alkalis. That's why we specifically know that it is in the alkali. So here only the one which are alkali can be formed by this method. One which are not alkalis cannot be formed by this method. The next one is base from salts. So we have over here salt solution plus base giving you normal salt plus precipitate of basic hydroxide. So it is going to be this way, that it will be third one is salt. We have got over here as salt solution. Salt solution, I'll just erase this part. Salt solution plus base is going to give me as normal salt plus the precipitate of hydroxide or precipitate basic hydroxide. Okay, so the example over here is AlCl3 plus the base given over here, this 3NaOH, is going to give me over here NaCl, yeah, 3NaCl plus it will going to give me NaLOH thrice, and this will be a precipitate, so arrow downwards. Understood? Aluminum chloride reacting with a normal base KOH is going to give me NaCl plus AlOH thrice, that is a precipitate, that is a insoluble base aluminum hydroxide. The same thing can also be taken with ferrous sulfate. If I take ferrous sulfate, FeSO4, it will give me Na2SO4 and FeOH will be formed over here. So aqueous solutions of salts with a strong base, okay, aqueous solution of salts with a strong base. Now this has to be a strong base, similar to what we have over here. It was a non-volatile acid. It was specifically required. It should be a non-volatile acid. Similarly over here, we require a strong base. We cannot have a weak base. We want the dissociation to be very, very, very high. Okay, that's why this plus this strong base will give me a normal salt first, and also going to give me a precipitate of the base over there, that is precipitate of basic hydroxide. The last one is bases by decomposition of salts. So we have certain salts. When certain salts are going to be heated, they are just going to give you that oxides of metal. So we have this particular thing, like we know that carbonates when heated will give you the metallic oxide plus carbon dioxide. Nitrates when heated will give you metallic oxide plus my nitrogen oxide plus oxygen. Similarly over here. So here we have over here the next thing, the fourth one is by decomposition of salts. The salts, when they decompose, like PbNO3 twice, that is 2PbNO3 twice, is going to give me 2PbO plus NO2 plus O2. Now this is what I am talking about, is the metallic oxide. The metallic oxide, we know what is the definition of base. All metallic oxides, metallic hydroxides and ammonium hydroxide. So this is a metallic oxide, hence this is a base. So when you are having a decomposition of a salt done, what you get is a lead oxide. The lead nitrate gives me lead oxide. Lead oxide is nothing but the base. The nitrogen dioxide and oxygen will be released during the same. Okay, so this was about the preparation of the acid and bases. We can quickly go through the physical properties of the acid and base in this video, and then we'll go to the chemical properties in the next video. So we can see over here the first thing about the physical characteristics of acids and bases. So if I see a particular kind of a compound and I want to find out whether it is acid or base, how physically I can find it. Of course, some things are possible to be done and something not. Like for example, the first one is physical properties of acid is sour in taste in aqueous solutions. The first thing is they are sour. So we know that acids are going to be sour in taste, but of course don't try to taste it. We cannot taste the thing. We never know how burns you can get. And over here in case of base, we know that it will be bitter. So here, of course, you are not going to taste this either. Both could be very dangerous for your health. That's why it is. But yes, we know sometimes even by the smell we can come to know that it is sour in taste. Like कभी-कभी वो खट्टा पता चलता है हाँ कुछ खट्टा बन रहा है. So similarly, yeah, this is sour and this is bitter. Then next is these are highly corrosive in nature. Okay, they are highly corrosive in nature. So we have that mineral salts are highly corrosive, whereas the bases, which are caustic alkalis, are also highly corrosive. So you cannot differentiate as such, but yes, you can know that the physical properties may this is highly corrosive too. Okay, so acids and bases, the mineral acids and caustic alkalis, they both are going to be highly corrosive in nature. Finally is the indicator. In case of an indicator, if I am taking a litmus paper, then the blue litmus turns red. Here, red litmus turns blue. I remember this way. Red means danger, acid dangerous. Hence, when blue turns red, it shows me it is dangerous. Hence, it is acidic. So, blue turns red, acidic. Red turns blue, basic. So, this is how the acids and base are classified, or we can say the physical properties of acids are, they are sour to taste, highly corrosive in nature, especially the mineral acids, and blue turns red, litmus paper turns red. Same way in bases, it is bitter to taste, highly corrosive in nature, especially the metallic caustic alkalis, and they are red in, so the red litmus turns blue. So this was about the physical properties. The next time what we are going to see, it will be the chemical properties of acids and bases, and also some indicator parts. Okay.